Thanks, Mike, for your time. I really appreciate it. I know you're busy, so I really appreciate you taking the time to chat with me. So um, let's dive right in. And can you describe what Apollo Fusion does?
Sure. We make propulsion systems for satellites, and they're electric propulsion systems. They use the uh, power from solar panels and batteries, um, and it's a type of ion engine where you're accelerating ions very fast. They're exiting um, the engine at about uh, 12 kilometers a second or more. Um, and it's much more efficient than chemical propulsion. Uh, and a lot of satellites going up today are interested in highly efficient propulsion systems, trying to maximize the mass they can get up there, and minimize the power, and minimize the mass of the systems, and maximize the mass of the payload they can get up.
Right.
So we're making propulsion systems for these satellites.
Okay, great. And so Hall effect thrusters, those are one type of ion thrusters, and that's what you guys are focused on, correct?
That's right. Yeah.
Okay, great. And what's the difference between your technology versus what's currently out there?
Well, there's a Hall effect thruster and a chemical propulsion. They're very different. Chemical propulsion basically will typically combine a fuel and an oxidizer, and it'll be an exothermic reaction. It'll generate a gas that's thrust out at a high speed. Um, but the high speed is relative. The exhaust speed for the gases from chemical systems are an order of magnitude lower than typically ion thrusters. And the ion Hall thrusters will be typically 3 times more efficient from a mass perspective to velocity change generated. So you'll get 3 times as much change in velocity for the same mass of a propulsion system. Yeah, so that's the difference between the typical propulsion systems on satellites today.
Okay. And who would be or is your customer or your target customer?
So it's an exciting time to be doing stuff for space now. There's lots of satellites going up, a lot of satellite constellations going up. A lot of people announce constellations. Everyone's seen SpaceX has a Starlink constellation. I think they have 600 satellites up or something now. OneWeb has a constellation. They're going through some financial difficulties, but they have a constellation. Telesat is working on a constellation. There have been also government projects. The U.S. DARPA has announced something called Blackjack, which would be 100 satellites. The military is trying to get a more sort of basic satellite that different users in the military can use. Instead of having a custom satellite for every user, have a sort of a standardized bus, and then have the military put different payloads on it. So yeah, there's a lot of both commercial and government are putting up a lot of constellations of satellites typically for communications or Earth observation, putting satellites up to look at the weather, look at resources, look at where wildfires are, ocean ships are, illegal fishing is, climate change, lots of applications, weather for Earth observation satellites. Yeah.
So one of these companies would license your technology or would hire Apollo to actually manufacture the thrusters?
Typically, they'll buy thrusters from us. They will specify what's needed. They'll say, we want a thruster that can do this much impulse and have this much minimum thrust and have this much efficiency, meaning how much fuel do you have to load in order to get this much change in velocity. And then if we can meet their specifications, then they will buy these thrusters from us. They will attach them to their satellites, put the satellites in a rocket, launch the rocket up into space. And now the rocket will typically drop them off at a very low orbit, maybe 200 kilometers up or 150 kilometers up. But typically, the satellites want to be at 500 kilometers up, or 600 kilometers up, or 1,200 kilometers up.
I
Sometimes
see.
geosynchronous satellites will go to 43,000 kilometers up.
Okay. Okay. Very interesting. And I know we have a new case study that just came out, and one of the things that Apollo emphasizes is the ability to manufacture in volume those thrusters. Can you speak to that a bit?
Sure, that's exactly right. When we started the company, uh, we wanted to focus on the larger constellations from a business perspective. A lot of times, it takes quite a bit of work to work together with a satellite vendor um, to fit your propulsion system into their satellite. There may be thermal constraints. If your thruster is too hot, it may impact their payload. Or if your thruster needs to be kept warm enough, they need to change the satellite in order to keep the thruster warm enough or cold enough. Or there may be electromagnetic interference issues. I mean, a thruster, because it's an ion thruster, plasma there, it may potentially cause issues with their communication antenna and communication equipment.
Oh, interesting.
And there may be issues with just fitting the tank inside their satellite. It's usually like a game of Tetris. You're trying to squeeze a lot of things in a small box. So we do all this work to make sure that the volume fits, the mass fits, the thermal conditions work, the electromagnetic interference is fine, and that can take a lot of time and money. And if you're only doing it for one satellite, it's harder to make your business model work. But it takes almost the same amount of work to do it for one satellite as it does to do for someone who has 100 satellites. That's why it's easier from a business perspective to work with someone who's putting up 100 satellites or 200 satellites or 300 satellites. Yeah.
Okay, that's very interesting. And now that we're talking about that, could you share how Apollo Fusion got started? I'm curious how long ago and how it got started.
Well, we actually started doing something very different. We were doing nuclear fusion. Nuclear fusion, it's amazing if you can make it work. You're basically taking two hydrogen atoms, squeezing them together, turning it into helium, but in the process, releasing a lot of energy. That's why the sun is powered by fusion, and it runs for billions of years, fundamentally by taking hydrogen, squeezing it together to get helium, and releasing energy. So we were working on that, and at first we were making great progress. We were making very steady increase in our the neutrons per second generated. But that rate of progress slowed down, unfortunately. And as we started to calculate, how long did it look like it was going to take to reach the magical break-even amount for fusion, and how much money we had left, we thought that it wasn't going to work. So we said we need to switch to a new idea. And the good news, though, is there's an amazing amount of similarity between the plasma physics involved in nuclear fusion and the plasma physics involved in a Hall thruster. And in fact, a lot of the team who were building the fusion reactor had experience in Hall thrusters. So as we made the switch over to Hall thrusters, we could use a lot of the team was directly applicable experience, and a lot of the equipment was quite similar. The vacuum chambers we're using for fusion were very similar chambers to the ones we use for Hall thrusters.
Wow, and I didn't know about this until one of our customers, Kairos Power, saw the case study, and then they told me, do you know that they started in the nuclear energy industry? So
yeah,
it's interesting to see a pivot it just seems like a radical change, but now that you're talking about the similarities, but it's just typically people think of pivot like I'm building an app for this user base and now I'm pivoting to, but it just seems like such a radical change.
So I mean, I've had 5 startups as CEO and co-founder, and for good or bad, 4 out of the 5 have pivoted, and this was actually one of the easier pivots. Strangely enough, it was harder. It was harder in the past with some of the other ones to do the pivot we did. Yeah.
Wow, that's an interesting point. And your background, right? Your bachelor's and masters are in aerospace. So Was it always in your head to build a startup in aerospace, or it just happened?
It's funny. I wasn't planning on doing a startup in the aerospace industry. It's fun for me. I actually
Right.
get to use some of the stuff I learned in, at MIT a long time ago. It's fun for me. But no, that wasn't. It was just kind of a strange path that led me back to aerospace.
Wow. Wow. That's really interesting. And I guess you were doing some aerospace at Google, right? You were at Google for 6 or so years, right?
That's right, which is another strange path. All roads lead to aerospace. Google
Seems
Google
like.
bought my fourth company, and for a while I was part of the leadership team for the main Google search engine, which was
Mm,
really exciting. It was $40 billion a year in revenue back then, um, and we focused on all the stuff you're familiar with search. Different languages and image search and search suggestions and the knowledge panel on the right hand side, all these things.
mm,
Um, and it was exciting. But after a while doing that, I kind of missed different type of technology, different type of also different scale. I like the more startup type environments. But Google was very, very nice, and they said, no, we have something here that's good for you for that too. And they said we have this group called Google X, which
mm,
works on kind of the advanced, cool startup-like projects. And it happened to be an aerospace project. They knew that I had startup experience. They knew I had a background in aerospace engineering. And they said, why don't you come take a look at Project Loon? And I did. And I said, wow, this is
mm.
crazy. This is crazy, crazy, crazy. But let's give it a try. And so we tried
Wow.
it. We were flying balloons 60,000 feet up. Some of these balloons were flying around the world for, almost 2 years. We were able to get, from the cell phone in your pocket, you can get, let's see how old, you can get 2 or 3 megabits per second down from a balloon that's 60,000 feet up, just with the LTE in the phone you already have. So yeah, it was a very exciting project. We're rolling out in Kenya this year. So there's people in Kenya now getting commercial, internet use from balloons by Project Loon.
Wow, that's amazing. And I can exactly remember the first time I saw the video about that project. And I remember where I was, and I just remember just the impact that it had on just my idea on what I can do as an engineer and the type of challenge that we can. And honestly, to me, it was kind of merging this, being able to help people, and at the same time doing something like it's a massive engineering task, right? So yeah, that's exciting. And then, so I guess you left Google, and then right away you started Apollo Fusion, right?
Yeah.
Um, Going back to aerospace, what do you think of the aerospace industry as kind of the ecosystem to build a startup?
Oh, it's so much more fun than when I was doing it a long time ago. When I was right
Mm,
out of just out of MIT, I went and worked at an aerospace company for 3 years or so. And back in those days, it was a long time ago. Back in those days, it was a very slow process. You'd spend maybe a year writing a proposal
mm,
for a project. You'd wait 3 or 6 months for them to make a decision. They would award a contract to you. You'd spend maybe 3 years designing a satellite, and then maybe 2 years building a satellite, and then
wow,
maybe you'd wait a year until you could get a launch slot, and then you'd launch it. And this is he's talking about 7 years, 8 years, sort of from starting to or launching your and it would cost hundreds of millions of dollars for the satellites and hundreds of millions of dollars to launch it. Everything was $500 million.
right,
Um, these days, it's so much more fun. I mean, you can pretty much get on a launch vehicle within a month or two. There's half a dozen launch vehicles now. Obviously, SpaceX just launched another one this afternoon. They're launching 2 times a month or 3 times a month or something.
right.
There's Rocket Lab. There's Virgin Orbit. There's a company called Astra who's trying it. There's lots of different launch vehicles going up, and the cost is a lot lower too. Some
Mm,
of the prices you can launch for $500,000 or $750,000 or
Right.
$1 million. Um, and the speed at which you can design and build things is a lot faster. I mean, a lot of the technology we use today, like inertial measurement units, again, going back to cell phones, there's so much technology in a cell phone, an inertial measurement unit, which tells you which direction the cell phone is pointing. You can take those chips and use them for satellites. The microprocessors in cell phones, you can take those and run satellites with them. So yeah, there's a lot cheaper components today, and a lot more ability to create satellites quickly and get them up quickly and launch them relatively for a lot less money than it used to be.
So the industry is not reserved anymore for just like government or huge corporations with deep pockets, right?
Right. You have
Right.
startups. You have starts like Apollo Fusion in the industry, and lots of little companies putting up very small satellites for not a lot of money.
Right. And from the JKI perspective, definitely we've seen just more customers in aerospace. And from the way I see it is like alumni from like SpaceX, Virgin Orbit that started building startups and other different startups like Apollo Fusion. And it just I think I agree with you. It seems just more exciting, just
Yeah.
faster pace.
Yeah.
Um, and can we maybe let's take a step back and can you talk about the experience of building a hardware startup as opposed to a software startup? I know that in just conversations that I have with like VCs and people in the industry, kind of like hardware and the cost of infrastructure sometimes seems something that VCs don't want to get into unless they're specialized in that area.
It's harder, and sometimes some days I miss the days of doing a software startup. There are some um, there are some advances that have happened though that make hardware um, faster and easier in the old days. For example, and without being a paid plug for you guys, I mean the stuff you guys, your software, JKI software, stuff like that makes our job easier. I mean, I mean, we can have a small number of our team, but we can use tools like you have and like your team to quickly automate a lot of the things we do, like automate as you know, our vacuum chamber testing. So we can test 24/7 by using tools like you help us provide, and we can that lets us leverage a smaller team to move faster, even with things like hardware. And we try to do the fast iterations with hardware. We try to focus on how long does it take to take our vacuum chamber from 10 to the minus 6 torr up to room pressure, make a change, and get it back down to 10 to the minus 6 torr again. Some places that can take 6, 12, 15 hours to make a sort of a round trip. We try to make it very fast. So in less than an hour, you can do a cycle like that, make a change to your design, and test it again. So yes, we try to apply some of the techniques of software startups, which sort of rapid iteration, test as quick as you can, figure out what is working, and release a new version. We try to do the similar things with hardware, although it's now for hall thrusters for
Right.
space. Yeah.
Okay. And now that you mentioned it, let's talk about the collaboration with JKI. So I was looking through my emails, and the first time that you and I talked was almost exactly 2 years ago.
Yeah.
And from that day, we started with a code review, and then we started doing kind of an architecture design. And
Yeah.
it's been 2 years where we're on a monthly basis providing new features and things for your team. So
Yeah.
I'd love to hear a little bit more from your perspective what the collaboration with us has meant. And I know you mentioned speed a lot, just that kind of that's the key for startups. So I'm curious to hear your perspective.
Yeah. I mean, it's a balance game always with a startup where um, if you hire too big a team before you have enough revenue, your expenses get too high, no revenue. You're at the risk of running out of money. So it's a balance of trying to not make your own team too big, but also be able to still move fast.
Mm-hmm.
And that's why, it's been great working with JKI, because we can, have your tools and also your consultants who can speed up the stuff we're doing and keep our burn rate low, the number of hires, because we're not hiring additional people to do that. We're on a month-to-month contract with you guys to help us out. And that lets us really develop our technology faster while keeping our expense rate low.
Interesting. And the way that I try to communicate the value of JKI to our customers is similar to what you're saying, where we can come in and we can accelerate development.
Yeah.
And when I think of what it takes to hire new team members, and just in terms of time, just working with JKI, we definitely accelerate development. So
yeah, it's like if we were going to do some of the things that you've done for us, it would take us whatever. It would take us 500 man hours to write some of the things. And your team says, oh yeah, we have a template to do that. Or yeah, we built something like that for another customer. We can use the core of that, to help for your application. Or, we have tools that we've done for 20 of our customers that we've had to solve that thing because we have to solve it over and over again. Instead of you having to solve it all, you can leverage what we've done. And that's much, much more efficient for us.
Right.
Yeah.
Right. Great. Talking about the test lab, can you describe some of the tests that JKI helped automate, and in general, some of the tests that you do at the Apollo Fusion Test Lab?
Sure. So like one test that a lot of customers want to see is basically you want to see how rigorous your thruster is. So you say, turn it on and off a bunch of times. For example, 12,000 times. So one of the tests we did using the software you helped us do was we turned the thruster on, let it run for a couple of minutes, turned it off, wait for a couple of minutes, turned it back on again. 12,000 times. Now, if we'd done that ourselves, it would have driven someone crazy. That would have quit, Right. But with using your automated software, over the course of a couple of weeks, we just like, okay, how far along? Yeah, another 3 days, we're done. And we went, other people were doing other work, building other things, and then we just came back and it was done. So that was a cool example.
Yeah, and I know that I remember that at the point where you and I chatted first, you had existing software, but there were concerns about, can we run for, like you're saying, 12 hours with the software without having an error, right? And
well, also, frankly, we got a lot of smart engineers who know how to write, LabVIEW code, which works, sort of. But they'll be the first to admit, if we want to try to get, ISO 9001 certified, or if we're going to have one of our large aerospace companies say, what's your quality control on your software? If it was just what our engineers kind of hacked together, late at night, not so sure that LabVIEW code would pass the quality bar of an ISO 9001 or one of our large aerospace customers. But since you have done it and you're more rigorous about your methodology, it does pass. And you have code control, you have source control, you have your repeatability, you have tests, unit tests that you do on the code. All that it makes it much more robust and makes it much easier to get certified from a quality standpoint.
Right. I mean, that makes sense, and I agree with that. Taking a step even just a little bit towards the beginning of our conversation, and what do you think is the future of the aerospace industry with all of these changes happening rapidly and constellations of satellites going up? Do you have any, I don't want to say predictions, but just any idea on what the future is going to look like for the industry?
Yeah, I don't know. It's kind of exciting. You see, when SpaceX just sent the manned capsule up a couple of weeks ago, and they got off the Dragon and got on the International Space Station, and then NASA's kind of talking about they're going to allow more commercial interactions with the space station. So more companies will say, well, yeah, I want to try an experiment on the space station. in a zero G environment. I think space tourism is kind of really exciting.
Hmm.
SpaceX is going to let people fly. Virgin Orbit's going to let people fly. Virgin Galactic's going to let people fly. Blue Origin is going to let people fly. Hey, I want to ride. I want to go into space. I want to.
Right.
I want to do it. I want to be a customer. Um, I think you'll have first it'll be rides up into orbit and then go around a couple times, then come down, whatever. But I think I in my lifetime we're going to have space hotels, right? And people are
Hmm.
going to for their honeymoon, they're going to go in space. That's it's going to be the new whatever going to Hawaii or whatever. You're going to say, we're going for our honeymoon. We're going to space. Um,
Wow, I hadn't thought about that
yeah,
application. Yeah.
it's going to be cool. And yeah, I think it's going to be cool.
Wow. Wow. Um, any advice that you want to share with any people trying to build a startup in the aerospace industry? I know that um, again, you mentioned speed in general as the key of your success, or
Yeah.
one of the keys of your success. But specifically to aerospace, is there any advice that you would share?
Yeah, I mean, in some ways, it's similar to any startup company.
Mm,
Try to keep your expenses as low as you can. Try not to get for your translates to how much runway you have. You don't want to have like 2 months of runway or 3 months of runway before you run out of money. Try to have a nicer amount of runway.
mm-hmm.
Um, try to have your products be tested or in the hands or be have real customers get hold of your product and say, yes, I want this, or no, this is what's wrong with it.
Mm-hmm.
Don't spend like 3 years, building something and then show it to a customer. I would say show it to a customer, 1 month
Even if
after.
it doesn't have all the features
Yeah,
and right.
absolutely. I mean, that's the Reid Hoffman famous saying is if you're not embarrassed when you release your first, product, you waited too long. Because you got to show it when it's kind of ugly, but it's got some functionality that's interesting, and let people say that's ugly, but oh, what it does, that's pretty good.
Right.
You want to find that, and if they're like, no, it's ugly, and I would never use it because of this, then you don't want that. But what often happens, I think, and it's happened in all 5 of the companies I started, is you show people stuff, you build something, and maybe not the first thing you build is what you're successful. But you get this feedback. They say,
Mm-hmm.
that's kind of okay, but it'd be really good if you could do this. And after the 5th person says, it'd be really good if you could do the same thing, then you're like, okay, I'm going to build that thing. And that's what has worked for us. We definitely got the feedback from customers, and we said, okay, we'll build it. And that's the surest way of having people want to buy your stuff is if they told you exactly what they want.
Right, of course. And
Yeah.
how important it is to find the right customers, right? Is that the toughest part, do you think, at the
Uh,
beginning?
it's tough. It's tough first getting credibility at the beginning. People are like, I've never heard of you.
Mm-hmm.
And then after you establish credibility and you get some contracts and people start to hear, oh yeah, I worked with Apollo. They were good. Oh
Mm-hmm.
yeah, you should have seen what Apollo did. That was really good. They did what they said they would. When we tested it, it was exactly what they said. Then you're like, okay, you gain some credibility. It takes a while. It doesn't happen in the first 3 months or 6 months or 9 months. It takes a while, but then when you finally get the credibility, it's great. People start calling you. You don't have to call them. They're like, yeah, I've heard about your thrusters. I'd like to get some of your thrusters. So that's when it's fun.
Wow. And maybe let me end with one question just about the future of Apollo. What's coming up for you guys?
We've got some really exciting contracts. Unfortunately, I can't talk about them. They're all commercially. They want to have a non-disclosure, and the military ones, it's totally you can't talk about those either. But yeah, we have a number of ones that are very exciting. Some of them are uh, communication satellites close to Earth. Some of them are far away from Earth. And some of them are commercial, and some of them are government. But it's fun. It's fun.
Wow, that's incredible. Um, I want to end the interview there. I really appreciate your time, Mike. It's been awesome working with you and your team. and we look forward to continuing the partnership and look what you guys do.